Hello students, my name is Ankur. I have done AmTech from MNIT Jaipur in 2017. After that, I am in teaching profession. I am teaching engineering mechanics. So let's begin with our fourth lecture. So our next topic is truss. Truss can be 2D or 3D, but in our syllabus, truss is only 2D. Well, we will study the truss which is in 2D, or the truss which is in 2D. It's called the plane truss or trusses. Okay, so let's see what the truss. It is the rigid structure. Rigid, I told you earlier in the first lecture. Rigid means it structure will not be deformed, right? It will be rigid, fix रहेगा वो. उसकी shape and size change नहीं होगी by giving any load. Okay, so it is the rigid structure in which all the members are subjected to either axial tensile or axial compression. ओके, उस पे मतलब जो भी मेंबर्स हैं उन मेंबर्स पे दो टाइप के ही लोड लग सकते हैं. दैट कैन बी आइदर एक्सल टेंसाइल और दैट कैन बी आइदर एक्सल कंप्रेशन. ओके, एंड हैव नो बैंडिंग मूवमेंट. मतलब रिजिड स्ट्रक्चर में जो आपके मेंबर्स हैं उस पे कोई भी बैंडिंग मूवमेंट नहीं होगा. राइट, बैंडिंग मूवमेंट इज जीरो एवरीवेयर इन द स्ट्रक्चर. राइट, दिस इज द truss. So let's see the truss. So in this example of truss, it is composed of the members. The members, this is AB, BD, AD, DC, CE, and DE. Okay, these are the members. So how many members are there in this? This is the first member, second one, third one, fourth one, fifth, sixth, and seventh. So this truss is composed of 7 members, right? Let's see what other things are there. In this truss, the two links, the two members are being joined by the pin. This is called the pin joint, or you can say it's a hinge. Okay, this is a you can say this is the hinge, right? So any 2 or 3 member which are joined, that joint should be pin joint or hinge, right? So how many joints are there? This is the first, second, third, fourth, fifth. So in this 5 joints are there. Let's see what other things are there. In this, there are 2 supports. One is at A, one is at E. The support which is at A is called knife support. But knife support gives only the vertical reaction, but this is having the joint. So this knife is called hinge support. This knife is called hinge support. Why? Because it's having the joint, pin joint at the support. So it having the 2 reaction at this point. I told you earlier the first lecture that whenever we see the hinge joint or hinge, so it having a 2 support, one is at the vertical and one is at horizontal, right? Let's see the second one. This is the setup in which there is a horizontal surface. This is a fixed surface, horizontal surface, this one, and over this there is a roller. This is the roller, yeah, you can say rolls, और उसके ऊपर ये आपका hinge support है. बट बिकॉज ऑफ द रोलर ये कोई भी सपोर्ट आपका हॉरिजॉन्टल डायरेक्शन में नहीं दे पाएगा. सो दिस सपोर्ट इन हॉरिजॉन्टल डायरेक्शन विल नॉट बी देयर. व्हाई? बिकॉज इसको हल्का सा भी फोर्स मिलेगा इस साइड में, सो इट विल मूव, ये मूव कर जाएगा. और इफ यू कैन से इसको हल्का सा भी इधर फोर्स मिलेगा तो इट विल मूव टुवर्ड्स द लेफ्ट, राइट? सो इट विल नॉट गिव एनी reaction towards the horizontal. So roller, this is called the roller support. Let me write. This is called the roller support. And what is the property of this? It will give only the vertical reaction. It will give only the vertical reaction. Vertical reaction ही दे पाएगा ये, क्योंकि horizontal इसको आप force मिलेगा तो it will move. It will have the rollers. It will move. Okay, why this roller support is provided? Because of the rough condition of environment. In environment you can see the summer season as there is a winter season as well. So in this, because of the temperature variation, this thing can be contract, can be extend. Sorry, this thing can be contract, can be extend. So if this extends, so this E point can move horizontally, and if this contracts, then E point can come near. So because of this expansion or contraction of the material, because of the variation in temperature, this one roller support is provided in the truss. Okay. So as we have understand what is the truss, so let's understand what are the conditions that to be fulfilled to say the structure is a truss. Okay. So let's see the condition. First condition is all the members should be either pin joint or hinge. Okay, as we have said this earlier, because like this member AB and this member AD, that should be joined either pinned or hinged. Okay, the member AB, BC and AD, all these three member should be having joint which is pin joint or hinge. This is the first condition. Okay, next condition is the load should be applied at the joint of the member, right? तो जो भी आपके joint है, इसी joint पे load apply होना चाहिए. It should not be like कि आपने load यहाँ दे दिया, ठीक है? ये गलत हो जाएगा. कहाँ देना चाहिए आपको? Load आपको देना चाहिए joint पे. So truss में जो भी आपका load होगा, that load should be at the joint here, at the joints. You can also apply here. Okay, you can also apply this here, right? So at the joints only you apply the load. Okay, let's move to the third condition. What third condition says? Only concentrated point load should be applied. That means हम जो भी joints पे load दे रहे हैं, that should be the concentrated load, right? Joints पे आपका कोई भी like कोई भी UDL या कोई भी इस टाइप का load नहीं आना चाहिए, right? So these are the conditions for the truss. So let's move to the assumption of truss. Assumption, क्या assumption हम लेते हैं to like solve the questions. The first assumption is that the member should have the weight or negligible weight, no weight or negligible weight. That means the member should have a mass which is equivalent to 0 or very negligible mass. Because अगर इसका मास होगा, let's say ये हम बात कर रहे हैं BC लिंक की, BC लिंक का मास होगा तो that mass will be applied at the center. ठीक है, और हमने अभी बात करी थी कि that load should be applied at the joints, right? अगर इस BC member का मास होगा, so this joint will be, so this load will be applied at center, तो ये इसको avoid कर देगा. So our assumption is that कि जो भी इनके masses हैं, that should be very less or no mass, right? So let's move to the second assumption. Second assumption क्या बोलता है? A member should be joined at the ends. ठीक है? Second assumption ये बोलता है कि आपके जो भी member, आपका member AB है, BC है, BD है, तो they have the second member. ठीक है? Second member हो, but that should not be at the mid या कहीं बीच में से ना हो. ठीक है? तो ये member नहीं चलेगा. आपको फिर यहाँ पर एक जॉइंट देना पड़ेगा, इन दोनों मेंबर को अलग करना पड़ेगा. ठीक है? सो द मेंबर शुड बी जॉइंट एट द एंड्स में ही आपके मेंबर जॉइंट होने चाहिए, बीच में से कोई भी मेंबर आपका जॉइंट नहीं होगा. दिस इज द assumption. ओके, सो लेट्स मूव फर्दर. So the next is perfect truss. When we say the truss is perfect, it's having some condition in it. As we know, the trust is made up of two things. First is the member, and next is the joints. Members and joints. So when we say that trust is perfect, when it have a sufficient number of members, so that the load that is applied on the thrust will not able to deform its shape. जो आपके thrust की shape है, that will not change when we apply the load. So it has sufficient number of thrust. Sorry, sufficient number of member. So what is the number that should thrust have? That's the number of member that should thrust have, so that we can call it that is the perfect thrust. Okay, so let's say that the member is M, which should be in the thrust. Okay, that member, if it equals to twice the joint minus 3, right? Where M is the number of member and J is the number of joint. Where J is the number of joint. Number of joints in the truss. Okay, this is the formula. And if this like 2j minus 3, okay, it's having the number of member, and this number of member is exactly in the thrust, then that thrust can be called as perfect thrust. Let's see the previous example. In this example, the number of members are, let's say this is 1, this is 2, 3, 4, 5, 6, 7. So it has 7 members. Let's see how many joints are there. The first joint is the first joint, second, third, fourth, and fifth. It's having joints 5. So let's see for the perfect test how many member it should have. So twice of j minus 3. So this is going to be 10 minus 3 equals to 7. So this, if this member is equals to the member which is in the truss, so we can say that this arrangement of truss, okay, this arrangement of truss is called the perfect thrust. I'm sorry, I have done the calculation here. This was this. Okay. Okay. So if we check this, like with this formula, m equals to 2j minus 3, right? We can get the number of member for the perfect thrust. And if it equals to the actual member of the thrust, then we can say that thrust is a perfect thrust. Okay. Let's suppose if any example in this, the members which we have calculated by using this formula, it come out to be more. It could happen. We also do some question for this case. What I'm saying, the member which we have calculated, right? Let's suppose the member which we have calculated that come out to be more as what the condition says, 2j minus 3, right? Like in this case जैसे ये है, in this case हमारे पास जो thrust है, मतलब for the sake of example, यहाँ पर हमने किया, यहाँ पर 7 आए थे काउंट करके. Let's suppose यहाँ पे 8 आते, and condition says it should be the 7, right? So what could be the हम क्या बोलेंगे उसको, ठीक है? If the condition is like this, right, then we will call that thrust is redundant. Okay, yes. What does this word mean? This word means it's having the thrust is having the axis member, right? Let's consider the case which is reverse of it. That means if, one second, yeah. If the member is less, the actual number of member is less, the condition says 2j minus 3, then the thrust is called as deficit, or you can say deficient, right? Deficient. So in the question of 2 or question of 1 in the GATE, you can have this like question, like you have given the thrust, you will calculate the member of thrust in the in this 1 2 3 करके आप इसको करोगे, calculate करोगे, and you will judge this with this condition. ठीक है? If this come out to be less, then the thrust is deficient, and it come out to be more, then the thrust is redundant, and it equals to this condition that the number of members is equals to the number of member it having the thrust, then the thrust is called the perfect thrust. ठीक है, मतलब ये आप एक्सेप्ट कर सकते हो कि क्वेश्चन आपको 2 मार्क्स में नहीं, मतलब हाँ 1 मार्क्स मिल सके. Okay, so let's move further. Now we will see how we'll calculate the reaction for the given example. ठीक है, so let's consider this as a one question. ठीक है, क्या करना है आपको इसमें? आपको इसमें रिएक्शंस निकालनी है. और रिएक्शंस कहाँ पे होंगी? रिएक्शन जहाँ पे आपके सपोर्ट्स हैं. तो सपोर्ट एट ए, सपोर्ट एट ई, यहाँ पे आपको रिएक्शन निकालनी है. ओके, सो लेट्स ड्रॉ द एफबीडी ऑफ दिस. लेट्स मी राइट. ओके, सो एज आई टोल्ड यू, यहाँ पर जो आपका हिंज है, तो यहाँ पर कितनी रिएक्शन होंगी? यहाँ पर 2 रिएक्शन होंगी. वन इज एट हॉरिजॉन्टल एंड वन शुड बी एट वर्टिकल. ठीक है, और ये आपका क्या है? रोलर सपोर्ट है. रोलर सपोर्ट में क्या होगा? आपके पास ओनली एक ही टाइप की रिएक्शन होगी, ये. ठीक है, इसको भी डाउनवर्ड ही बना देते हैं. ओके, so we can say that this is RAV reaction at A, which is in vertical direction, and this is RAH reaction at A, which is in horizontal, and this is RE, जो कि सिर्फ vertical में ही है, right? So how we should calculate, क्या करेंगे, मतलब क्या मेथड लगाएंगे इसमें? सिंपल, बिकॉज हमने पढ़ा था अभी इक्विलिब्रियम. So what we will say that this stress is in equilibrium state. ठीक है, इस पूरे थ्रस्ट को हम क्या मान लेंगे? इक्विलिब्रियम मान लेंगे, एंड देन वी विल सॉल्व फॉर दिस, राइट? सो व्हाट इक्वेशन वी विल अप्लाई? इक्वेशन क्या अप्लाई करेंगे हम इसमें? सेम जो हमने पढ़ी थी, दैट द फोर्सेस, द समेशन ऑफ फोर्सेस, वेक्टर सम ऑफ फोर्सेस डेट टू बी 0. इसका मतलब क्या था? इसका मतलब ये था दैट द फोर्सेस व्हिच आर इन हॉरिजॉन्टल डायरेक्शन, their sum should be 0, vector sum should be 0, and the forces which are in vertical, their summation also come out to be 0. And in this, if you calculate the momentum at any joint, किसी भी joint पे आप momentum निकालोगे, ठीक है, at any joint, वो momentum क्या होगा? 0 होगा. Momentum at any joint or any point, ठीक है, that should be 0. हम ये equations यूज करेंगे to calculate the reaction. Okay, clear? So let's move to the exact questions. ठीक है, this is our first question. और ये आपका सेकेंड, ठीक है। सो लेट्स बिगिन विद द फर्स्ट। सपोज यहाँ पे आपको दे रखे हैं दिस लोड इज 10 किलो न्यूटन, and this is also 10 किलो न्यूटन. Let's do it. First we will consider as equilibrium, ठीक है। तो हम क्या करेंगे, we will do the same thing. First we will take the forces which are in horizontal direction are to be 0. देखो यहाँ पे कितने फोर्स है हॉरिजॉन्टल में, एंड यू विल सी कि यहाँ पर सिर्फ एक ही फोर्स है, दैट इज दी आर ए. ओके, सो माइनस आर ए. वाई माइनस? बिकॉज इट मूविंग इन द, this pointed towards the negative x. So minus RA equals to 0. That means RAH equals to 0. So at this point A, at this point A, there is no horizontal reaction. यहाँ पे कोई भी horizontal reaction नहीं होगी, right? Okay. So let's move to next equation. Vector sum of all the forces in vertical 0, right? So जो भी pointed towards the downward होंगे, downward, we will take it negative y because they are pointing towards the negative y, and upward positive y, so we will take it positive. So RAV plus RE minus 10 equals to 0. So we got RAV plus RE equals to 20 kilo, right? We got this equation. To further solve it, we have to apply the third equation. आप किसी पे भी ले सकते हो, बट फॉर एक यहाँ पे अभी मैं ए पे ले रहा हूँ, मोमेंटम एट ए इक्वल्स टू 0, ठीक है। तो मोमेंटम एट ए हमने किया, सो देयर विल बी नो मोमेंटम बिकॉज ऑफ दिस आर ए, ठीक है। आर ए से कोई मोमेंटम नहीं आएगा। मोमेंटम का कहाँ से आएगा? मोमेंटम आएगा P1 से, P2 से एंड आर ई से, ओके। एंड व्हाट दैट शुड बी, ठीक है, ओके। हाँ, इन दिस क्वेश्चन, ओके, वन थिंग इज नॉट गिवन. Let's say this is the, all the length are equal, all the length are equal, they are given L, each member have the equal length, okay. So, and this is the, we will consider this is the equilateral triangle 60, because all sides are equal, okay. So जो भी लोड पड़ रहा है वो कहाँ पड़ रहा होगा? दैट लोड, बिकॉज यहाँ पे, सॉरी, क्योंकि यहाँ पर ये पे कैसे यहाँ पड़ रहा होगा, एंड दिस लेंथ, वो लेंथ कैसी हो जाएगी? दैट लेंथ, दिस लेंथ, ये लेंथ हो जाएगी L बाय 2, right? So the momentum because of P1 is P1 L by 2, and the sense is, sense क्या होगा इसका? Clockwise, and I am taking the clockwise as negative, ठीक है। सेम P2 से, P2 से अब क्या करोगे? P2 से आपकी ये एक तो एक लेंथ L होगी और एक L by 2 होगी जो परपेंडिकुलर है P2 डायरेक्शन से, so and it will also give the clockwise direction, so I'll take negative P2 into L plus L by 2, this L and this L by 2, ठीक है, टोटल यहाँ से पड़ेगा ये, राइट। एंड लास्ट इज आर ई, आर ई से कैसे आएगा मोमेंटम? आर ई into L plus L, so this will the anti-clockwise, I'll take is positive, so RE into L plus L goes to 0, right? Let's put the values of all this. Minus 10 L by 2, minus 10 into 3L by 2 plus RE into 2L. Let's cancel the L. सारे L cancel हो जाएंगे, right? And from here, this will be 5. This will be 15. 15 plus 5 is 20, and it come out to be RE equals to 20 by 2. That means 10 kilonewton, right? So from here we got this RE equals to 10 kilonewton, and we will put this in this equation, and we will find that RAV is 10 kilonewton. अगर हम इसे सॉल्व भी करें तो भी हम बता देते हैं आराम से. Why? Because ये आपका पूरा सब सारे आपकी लेंथ L है, सबकी लेंथ L है, तो यहाँ पे L by 2 भी पड़ेगा, ये भी L by 2 भी पड़ेगा, तो इक्वल डिस्टेंस है. और इक्वली जैसे ये मालूम पड़ गया आपका ये 0 है, तो हम ये बोल देंगे कि भाई इक्वल है, तो आराम से हो जाएगा. ओके, सो विद दिस स्टेप्स वी हैव टू डू लाइक दिस. ठीक है, और इंट्यूशन आपको खुद ही बोल देगा कि हाँ ये इक्वली आने वाला है. ठीक है, सो लेट्स मूव टू द एग्जांपल. नेक्स्ट एग्जांपल, दिस वन, राइट? ओके, हाँ, मेरे दिमाग में क्वेश्चन आया. आप इसको ऐसे भी कर सकते हो, आप खुद करके देखना. एक लोड इसका यहाँ माउंट कर दो 10 किलोन्यूटन का, एक लोड यहाँ माउंट कर दो 10 किलोन्यूटन का, राइट? यू जस्ट प्रैक्टिस दिस, आई विल टेल यू द आंसर. ये आपका 10, दिस इज द 10 kilonewton, 10 kilonewton. This is also 10 kilonewton. This is also 10 kilonewton. Okay, and all the length which is given. Let me give you the length. 1 second. Okay, so these are the dimensions of this member. Okay, ये आपकी length है member की, and these all are in meter. ये all are in meter. Okay, just solve this and have the answer. I'll tell you the answer. So these are the answer. Just try to solve this. Okay, if you want, we will take this in the lecture. Okay, and the direction of this horizontal reaction at A is this in that direction. Okay, it's towards the left. Okay, just try to solve. So let's move to this example. Okay, here also the dimension is not there, so let me write the dimensions. 1 second. Okay, so these are the dimensions. Okay, so let's take this question to next page. Yeah, you just pause this video and try to solve this by yourself. Okay, so as you can see, it have the two supports. This is one is the rotor support. It will give the only vertical to this AB. Okay, so here it will have the vertical support, but according to us it is a horizontal one. Okay, so let me write this is the RB. Okay, and this one is the hinge support. So यहाँ पर दो होंगी, एक होगा according to us one should be like this vertical and one should be up. So this is RAH, and this is RAB. Right? So let's consider that this whole thrust is in equilibrium, and apply the three equations. So let's do. So first we will take the forces which is in horizontal. And their vector summation have to be 0. So let's see, आपका एक horizontal में है RAH, RB, I think और कोई नहीं है. So RAH, it's giving towards the positive x, so positive. RB is, we have taken all in positive, so positive. So this is the first equation what we got. Okay, now we will take the summation of forces in vertical. So vertical in this RAV 10 kilonewton and this one 10 kilonewton. So RAV is positive because we have taken this in positive y, and others are pointing towards the negative y, so I'm taking this negative. So from here RAV is come out to be 20 kilonewton. Right. The last we have to use the momentum balance. So कहाँ पे आप लेना चाहेंगे? 0 के लिए. So I'll choose point A. आप B भी ले सकते हैं. You will get the same answer. ठीक है. So point A मैंने लिया कि वहाँ पे आपका momentum क्या होगा? 0 होगा. So let's see. So at A the momentum should be from the point from this RB 10 kilonewton at E, 10 kilonewton at G. So let's take first from RB. So from RB, it will be RB into the length. Length कौन सी? Perpendicular to RB, it's 5. Given there, 5. And the sense is clockwise. I take as negative. Sorry, it's an anti-clockwise here. Positive. Okay. And from here, from this 10 kilonewton, distance is 5 plus 5, 10. And this is in clockwise direction, so I take negative. So this from the E point, 10 into 5 plus 5, 10. Okay, and please be careful with the units because this is in we have to calculate. This is in meter, this is in kilonewton, this is in meter, right? From this the load which is at G point, giving and clockwise direction, so minus 10 kilonewton into this 5, 5, 5, so 15 equals to 0. Here also its unit is kilonewton, this is meter. Okay, it's all right. So this is 100, this is 150. So 100 plus 150 is 250. So RB is equals to 250 kilonewton meter, and 5, as we know, this is in meter, right? So RB from here we have calculated, which come out to be 250 divided by 5, it's 50 kilonewton. We got this answer. And if we put this RB in this equation, what we'll found? We'll found that RAH is equals to minus RB. It means minus of 50 kilonewton. अब यहाँ पे what does this minus sign indicate? यहाँ पे minus जो sign आ रहा है वो क्या indicate कर रहा है? This minus means because we have taken the direction in positive x, but in actual this direction is not in positive x. This direction is in negative x. This right side. So this is the direction, actual one. ओके, सो घबराने की जरूरत नहीं है. आपका आंसर नेगेटिव आएगा तो सिंपल से मतलब ये है कि जो उस पे लोड पड़ रहा होगा, इट्स नॉट लाइक दिस, इट विल बी लाइक दिस. वन सेकेंड, ऐसे पड़ रहा होगा लोड. ठीक है, नो मैटर. ओके, सो वी हैव डन द रिएक्शंस. आई थिंक further we will move to solve the actual question. Okay, so that we will do in next lecture. So that's it for today. Okay, thank you.